Hey everybody, welcome to another lesson in the Science 10 chemistry unit. Today we're going to talk about naming ionic and molecular compounds. So we've already talked about how ionic compounds come together, talking about the cation and the anion. Today we're going to actually talk about how you go about naming them. So naming compounds, the whole purpose of it is that it helps us get rid of the confusion that can result from inaccurately naming the compounds. So example, blackboard chalk and the chalk and Tums. Okay, they both are chalk, but they are different. So naming compounds also shows the importance of using names that provide information about the chemical composition of a substance. And the International Union of Pure and Applied Chemistry, or UPAC, is a body responsible for naming all compounds. So if you're going to ask me later, why is that such a stupid name? Well, it wasn't to do with me, sorry. It's to do with IUPAC. So for ionic compounds form when electrons transfer from one atom to another. So example, sodium chloride, which is NaCl, also better known as table salt. So we have a positively charged sodium ion. Remember, it's not an atom anymore because we have a charge. So the positively charged sodium ions are attracted to the negatively charged chloride ions. The two kinds of ion groups together in an organized array called a crystal lattice. And the lattice is made up of one such sodium ion for every one chloride ion. And such a neutral unit is called a formula unit. So we can see from up at the top here, if we look at where we have sodium chloride right there, now we have NaCl. And this shows that we have one NaCl, or one Na to one Cl. And so that's what we're talking about here with the crystal lattice formation. We have a 1-to-1 ratio. So there's a picture right there of what, if you were able to look at the molecular structure of table salt or sodium chloride, what you would see under a really powerful microscope. Now recall that an atom of sodium has one valence electron. So an atom has one valence, not very stable, and a chlorine atom has 7 valence electrons, not as stable because they want to have 8, and that means they want to be like their most closest noble gas. So when the two combine, the sodium atom transfers 1 electron, because it wants to get rid of the 1, to the chloride ion, because it wants to gain 1. So as a result, both atoms now have full outer, and that should be not other, but sorry, outer energy levels. So that means they are stable. This type of bonding, or the transfer of electrons, is called ionic bonding because we're forming ionic compounds. And ionic bonds form between metals and nonmetals. So as we can see here, if we look at the sodium atom, with my mouse is going over, we have this 1 extra electron right here. We have the chloride or chlorine atom. It has missing 1 electron right there. And when we have our chemical reaction and bring them together, we have the sodium extra electron transfer to the chlorine. So now it gives us 8 in our shell out here and 8 in our shell here. And we can see sodium without a charge because we're dealing with an atom, sodium with a charge because we're dealing with an ion. And here's another picture just to show how the sodium electron transfers over to the chlorine atom. And then we get a sodium ion and a chloride ion, which together becomes sodium chloride. Now, some common properties of ionic compounds, and we'll get eventually to a lab where we're going to start testing these ideas, but they are, for the most part, solid at room temperature. They do easily dissolve in water, so a really good way to think about these properties if you just think about table salt. So on your table, it's solid. It dissolves in water if you put it in water. And solutions, and that should be of ionic compounds, conduct electricity quite well, actually. So if you were to just put some electrodes in water and transfer electricity back through, we would have, it would give a pretty good current. Now, if you were to put some electrodes in some water that you'd mix sodium chloride in, the current would pass through even better. Now, there are thousands of ionic compounds, and several have common names. But they also have some chemical names. So if you go to page 41 and you look at table A2.2, you're going to see some of the chemical names and the common names of some ionic compounds. Now, some of these, for example, I would like you to start paying attention to, start remembering some of the common names and some of the chemical names for them. And the state of an element or compound is indicated by a subscript. So S is for solid, L for liquid, G for gas, and AQ for aqueous. And aqueous is a compound or element that is dissolved in water. Now, all parts of ionic compounds, or all names of ionic compounds have two parts. Every ionic compound is made up of a cation and an anion, or in other words, made up of a metal and a nonmetal. And the naming rule works like this. So you name the cation first by the element's name. So it's usually the metal ion. So if we're talking about sodium chloride again, or NaCl, it's sodium. That's the basic element name right there. And then name the anion second by using the first part of the element's name and changing the ending to "ide." So it's not sodium chlorine, it becomes sodium chloride. And usually when you the anion is usually a nonmetal. So if we look here, just some examples, we have sodium chloride, cation is Na plus, anion is Cl minus and becomes sodium chloride. We have barium fluoride, we have F minus, we have Ba2 plus, and then it becomes BaF2. And we're going to talk about when we actually combine them, but just kind of give you a little hint right now. When you have these charges, what you're going to do is you're going to take this charge and you're going to cross drop it down. So the 2 plus charge that was with the barium drops down beside the F, and the 1, which was with the fluorine or the fluoride, drops down beside the Ba. And you don't normally need to write ones out, or you don't need to write ones out. And then next example, potassium nitride, we have N3 minus, K plus, which becomes K3. So the formulas for ionic compounds, they contain element symbols that identify each type of ion present. So in some formulas, the symbols are followed by subscript numbers. So like I was talking about there with the Ba2. So if I just go back a slide and you look at the mouse moving here, we have the BaF2. So in some formulas, the symbols are followed by a subscript. That 2 is a subscript. Numbers that are indicate the ratio of ions in the compound. So example, again, in BaF2, there's 1 barium ion for every 2 fluoride ions. So if you were to look at it under a periodic table, or under a microscope, that's what you'd see. And this represents the formula unit, or the smallest amount of the substance with the composition shown by the chemical unit. Now, all ionic compounds are composed of an equal number of positive and negative charges. So meaning the cations equal the anions. So example, we have sodium, which is Na plus, and Cl minus. Both charges cancel one another out, and therefore there's an equal number of positive and negative charges. All ionic compounds are composed of an equal number of positive and negative charges, so cations equal anions. So if we go here and we look at this example again, or not again, but AlC3 or Cl3, so aluminum chloride. So each aluminum atom loses 3 electrons, and each chloride atom gains 1. Now the aluminum ion has a charge of 3 plus, and the chloride ion has a charge of 1 minus. Therefore, every 1 aluminum ion combines with 3 chloride ions, and we can see that now by the chemical unit right here. The ratio is 1 cation to 3 anions, and thus the formula AlCl3. So if you look at this table on the next slide, we can see when we are going through the process, the first thing you want to do is identify the ions and their charges. So if I told you sodium chloride, you would find that sodium is Na plus and chloride is Cl minus. Next thing you need to do is determine the total charges needed to balance. So we both know it's just 1 plus, 1 minus, so we just have 1. Note the ratio, it's 1 to 1, and use subscripts to write the formula if needed. And because we have the same numbers, they can cancel each other out, don't have to write them. But if we look here at aluminum chloride, we know aluminum is 3 plus, chloride is 1 minus, so we have 3 here, 3 here, so it's 1 to 3, and then when we actually use the subscripts to write the formula, we'll just take that 3 and apply it to the chlorine, so we can get 3 chlorines to 1 aluminum to equal our charges out. Now another way of determining the correct formula for ionic compound, the first thing is you want to find the lowest common multiple of the charges for 2 ions. Second, divide by the combining capacity of 1 ion to get the correct subscript for that ion. So meaning, if you have one ionic compound that has a charge of 4 plus, so if you have a metal that has a charge of 4 plus and a non-metal that has a charge of 2 minus, you wouldn't drop the 4 and the 2. You'd take it to its lowest common denominator, and we know 2 goes into 4 twice and 2 goes into 2 once. So you then take it down and use the charges of 2 and 1. And that's all we have for today. So hopefully that's clear as mud for you. If you have any questions, please ask, and we will carry on and hope you have a great day.